It's been a while.
All right, ladies and gentlemen, there are a few things from the last lesson that I taught you that you really want to keep in mind. Now, I have made it a personal goal. One of the things I did this weekend was go to Costco. We were stocked really for my classroom candy because I kept stealing my kids' Halloween candy from home. So we were at Costco and my husband let me buy a giant thing so that I wouldn't keep stealing my kids' candy. So I am going to be intentional and pick at least 3 road to excellence each day, and this is my goal until Thanksgiving. So I need to get some more road to excellence in there. Raise your hand if you can tell me if you remember from last week, Thursday, when I taught you, what is I equal to? What is I equal to? Mario. Nice. Square roots of -1. Well done. And then can someone else raise their hand and tell me what is I squared equal to? Peter. -1. Nice. Okay, remember what I told you guys last week. The faster you can remember those 2 facts, the easier it will be to work with imaginary numbers. Now, we just looked on the bell ringer about what do you do if I is in the denominator? Basically, you can't have a radical in the denominator. Today, we're going to look at what if I is in the denominator, but also what if it's represented as a term? Quick reminder of what a term is. A term is separated by addition or subtraction. So if you're looking at I as a term, you might see something like this, because I is connected with a plus sign. In this case, we can't just multiply by I. We have to multiply by what is called a conjugate. You might have heard of a conjugate in your Algebra 1 background, but let me remind you of what a conjugate pair really consists of. Conjugate pairs consist of 2 numbers. You could say A and B, and the other pair still contains A and B, but what makes them conjugates of each other is one of them has a plus sign and one of them has a minus sign. Here's an example of conjugate pairs. Something like 2 plus I and 2 minus I would be examples of conjugate pairs. Let's think about why you would need a conjugate pair if I is in the denominator. And you might need to go back and think of a reminder of what happens when you multiply A plus B by A minus B. Raise your hand if you can remember. What does that simplify to? A plus B times A minus B. Haley?
The A squared minus B squared.
Nice. A squared minus B squared. So let's see how that helps us with when I is part of the denominator. Give me a road for that one.
They were laughing at me.
Okay, so if we are asked to divide, so this is how the directions will look. Therefore, if we are asked to divide and put your answer in standard form, like you did on your bell ringer, we need to use this concept. The directions say, evaluate the quotient and put your answer in standard form. Right now, we have 1 plus I. And as a quick reminder, this is like my thought bubble. This is the same as 1 plus the square root of -1. So obviously, I have a square root in the denominator, and I can't have that. So what I have to do to simplify is multiply by its conjugate pair. Right now, this is A plus B, and I need to multiply really by A minus B. And because it's a fraction, I can't change the value of the fraction. I have to multiply the top and the bottom by A minus B. So what would A minus B look like in this situation? Allison? 1 minus the square root of -1. And just to simplify our work, we'd write that as 1 minus I. But she's right. We're going to multiply by 1 minus I over 1 minus I. And I'm going to go ahead and multiply out the denominator first, just so you can see how this does get rid of the radical in the denominator. because we know it becomes a squared minus b squared, just like Haley reminded us of. And so in this case, a is 1, so I know it'll simplify to 1 squared, minus b is I, so I'm going to have minus I squared. 1 squared is just 1, but now here's the key. What does I squared turn into? -1. And then what is 1 minus -1? 2. Did we get rid of the square root in the denominator? Yes. So that's the goal. Now we need to continue. I have to simplify the numerator. I still have to put this into standard form, but that's why we needed the conjugate pair, so that we could get rid of the radical in the denominator. Mario.
Why does it become? Wait. Oh. I thought they were both negatives, so I thought it was gonna become parentheses.
It will become a positive because a minus a negative is a positive. Zinnia,
Why is it 1
why is it 1 minus I squared?
like for, yeah, this part.
We need, you need to get rid of I because I is a radical. So we need to multiply by the conjugate pair.
Oh,
So what we did here is we're multiplying by the conjugate pair to get rid of the square root. Really, we're getting rid of I because I is the square root of -1. Okay. Okay, now let's continue and simplify in the numerator. So the numerator, obviously, we need to distribute. So this becomes 2I minus 2I squared. Can I leave I squared? No, what does I squared equal to? -1, good. So this is going to become 2I plus 2. And if I want to put this in standard form, which part should I put first? 2 or 2I? 2, good. And then lastly, we can simplify this. If you want, you could just break it up into 2 different fractions. Call it 2 over 2 plus 2I over 2. But then you do want to reduce. What's 2 divided by 2? 1. So this is 1 plus I. All right, next question, letter B. Letter B, again, we have I in the denominator and we can't have radicals in the denominator. So to simplify, we're going to have to multiply by the conjugate pair. Right now we have A minus B. The conjugate pair is A plus B. So turn to your partner and let's do, let's do the person who was outside the longest this past weekend. You share what the conjugate pair would be. It's a weird question. Olivia, were you outside a lot this weekend?
Not much. I'm pretty sure you probably.
I took my kids, we went to the park and I tried to like take them on a run, but they were so funny. They were like, Mommy, Mommy, what's great?
Wait, say it. Wait, what was the part?
I took my kids to a park, but I tried to have them run to the park because we had a lot of donuts this weekend. We went out for donuts too. I was like, okay, let's go for a run, guys. Let's run. Mommy, pause break. Mommy, pause break.
Pause break.
Like, okay, guys.
I need to catch my breath.
It was fun though. Okay, so the conjugate pair would be 2 plus I and 2 plus.
And then you foil, yeah.
And now you foil, yes. Mario.
For the first one, for the first denominator, how did you know whether to subtract out the half?
It has to be the opposite. So the conjugate pair, the key of conjugate pairs is one is a plus and one is a minus. So if you start with a minus, you need to multiply by the positive.
That's not what I meant. I meant
Oh.
the second parentheses. Or in the second section. So in the bottom denominator.
Yes.
So on the other one, we did 1 squared minus I squared.
Oh, that's because A minus B times A plus B will always create A squared minus B
Okay, so it's
squared.
always minus.
Yeah. If you FOIL this, you'll see that the 2 middle terms cancel. And so it simplifies to this.
So you never floated really? You just wanted to.
Well, actually, guys, if I could have your attention really quick, this is what I'm kind of seeing some confusion on. If we FOIL this out, we will get A squared plus AB minus AB plus b squared, or sorry, minus b squared. And what happens to the middle two? They cancel. But this gives us a reminder that the denominator here will turn into a squared minus b squared, but the numerator does not have a plus and a minus. So what are we going to have to do with the numerator? Foil it, exactly right. The denominator, we can use this nice simplification that we know will pan out.
And that's because it's the same sign
It's because they're conjugates, because they're the same numbers with different signs.
for the bottom.
The bottom is what fits the pattern, the top does not. Okay, so as we simplify the bottom, what is 2 squared? 4. What is I squared? -1. What is 4 minus -1? 5. Awesome. We got rid of the radical in the denominator, but now we need to FOIL the numerator. So 1 times 2 gives me 2. Outside gives me 1i. Inside would give me, what's 2i times 2? 4i. And then last would give me 2i squared. I have some like terms there. I have 1i and 4i, which would give me 5i. So I have 2i, or sorry, I have 2 plus 5i plus, what is I squared turn into? -1. So Caleb reminded us that this will turn into a -2. And then what ends up canceling here? 2 and -2. So we get 5i over 5. And so the answer, yes, is I. Not bad, right? Worked out. It's just I. The key takeaway for these two beginning examples is you need to know to multiply by the conjugate when I is part of a term. All right. All right, guys, the next thing that we're going to be looking at is when do imaginary numbers show up in solving quadratics and how do we write our answer? So now that we have a better understanding of imaginary numbers, we want to start identifying when will we have real solutions like you guys did on that past test versus now when can we have imaginary solutions? And we're going to solve all of these using the quadratic formula, and any solutions that are imaginary, we're going to write in standard form, which, quick reminder, has the real part first, then the imaginary. So let's start. Quick reminder, the quadratic formula only works if the equation is first of all set equal to 0. And if it is, then do we remember the quadratic formula? I think you guys do. I was so impressed by tests that I've graded so far. It was like 98% of people had it memorized well. The only thing I did see mistakes with is this division bar has to be over the entire, like -b has to be included. Some people didn't have -b included in that. So I want to do a quick reminder. Now let's solve this with number 1. Number 1, what would be our A value here? Good. What's our B value? Good. And what's our C value? Nice. So let's plug this in. X equals -b, so that's -1. Plus or minus square root of b squared, so that would be 1 squared, minus 4 times the value of A, which is 1, times the value of C, which is 1, all over 2 times the value of A. And now I use my order of operations. So I have -1 plus or minus the square root of 1 squared is just 1. What's 1 minus 4? -3, good, all over 2. Now in the past, I would stop and say, woo, no real solution. But now you know that this is actually an imaginary value. So there is a solution here, it's just imaginary. And we have to stop and say, how do I simplify the square root of -3 using imaginary numbers? What is it? Super close. Remember, it's the square root of -1 times the square root of 3. And what is the square root of -1? But we do want to keep that radical 3. And I know this is tricky. If this was a square root of -9, then it would be 3i.
So you never put like a 1, like a -1? To do the radical for that?
No, you would simplify it to I. I'm almost done, but I do want to separate this into A plus BI. So I would just break this up, divide both of those pieces by 2 to show that the real part of this answer is -1/2. And the plus or minus, the imaginary part is I root 3 over 2. Now, this is how I've seen answers written in most algebra books. Your book likes to get really technical and they put I right at the end. So I would say either of these answers are good, but if you want to be like the book, you would put root 3 over 2I. They're the same because if you think about I, put it as I over 1 and you're just writing it before. So I will take either answer because I've seen both of them written in different textbooks. This book tends to focus on this way, but I will take either. Okay, now let's answer some questions. How many solutions are there? Why would there be 2? Yes, it's 2 because there's a plus answer and a minus answer. So we have -1/2 plus root 3 over 2I and -1/2 minus root 3 over 2I. Are these answers real or imaginary? Imaginary. Why are they imaginary? Because there's an I. What in our work caused us to have an I? Nice, the square roots of the negative. So that's nice to know that if you have the square root of a negative value, you know that you're going to have 2 imaginary solutions. Okay, let's move over to the second one. Number 2, you guys just took a test on a lot of questions like this, and we showed you how you can get rid of all of the fractions in one step. Mario? Yes. How would we get rid of all of this fraction really? What would we do to get the x out of the denominator? Caroline?
Multiply both sides by x.
Nice. Multiply both sides by the LCD. What's the LCD? X. So we'd multiply this side by x and this side by x. Let's start with the right side. That's easier. What's 0 times x? 0. And then let's distribute this in. What's x times x? Good. What's -3 times x? That's just -3x. Good. And if I distribute this here, think of this as x over 1. What reduces before I really multiply it? The x. Good. So we're left with just +3 equals 0. Now this is much easier to handle with the quadratic formula. What's our a value? Good. B is -3 and C would be 3. Okay, this time turn to your partner, see if you guys can finish this together. The person who spent the least amount of time outside this weekend, you share what you would put in for the quadratic formula. Olivia, you want to walk me through it?
Sure. Okay. So you would put the 3 plus or minus, and then yeah,
So,
and
oh yeah,
then,
yes, okay, so the opposite of -3.
sorry, yeah.
Gotcha, you just called that 3, gotcha. Of square root of,
And then it would be the square root of -3, which turns out to be 9.
okay.
Then it
Minus
would be
four,
-4 times 1 times 3, which
Nice.
then equals 12. Well, -12.
so 3 plus or minus square root of 9 minus 12, good. And then what is 9 minus 12?
-3.
Good. And then what do I simplify square root of -3 to?
So it would be a -1 times the -3, the
Okay.
root. So then that would be I times the root of +3.
Nice.
Yeah.
And then we would just break it up, right? So it'd be 3/2 plus or minus I root 3 over 2, or you could call that root 3 over 2I.
Yep.
So, all right, guys, go ahead and take a look. You should have 3/2 plus or minus I root 3 over 2, or you could say plus or minus root 3 over 2I. All right, let's talk about what we found. How many solutions did we get? 2. Were they real or imaginary? Imaginary. Why again? Because of, yes, the square root of the negative again. So that's how you know you'll have something with an I in your answer, if you have the square root of a negative. Okay, let's do two more. Hopefully you're going to be really good with the quadratic formula after today. Number 3, our A value is 1, our B value is 2, our C value is 1. And as we plug this in, we would have x equals negative b, so negative 2, plus or minus the square root of b squared, so 2 squared, minus 4 times the value of a, which is 1, times the value of c, which is 1, all over 2 times the value of a. So as I simplify this, this becomes negative 2 plus or minus square root of 4 minus 4, all over 2. What is 4 minus 4? 0. What is the square root of 0? 0. So if I did negative 2 plus 0 over 2 and negative 2 minus 0 over 2, would I get different answers? No. So what's the answer for x? Negative 1. So how many solutions did I find? Just one. Is negative 1 a real answer or imaginary? Real. There's no i's. And what caused us to have one real answer? What was it in our work? Yeah, the 4 minus 4. So really it was the square root of 0. So if you get the square root of 0, you're going to have one real answer. Okay, last and final use of the quadratic formula. What would be our A value in number 4? Good. B would be 10, C would be 9. So we'd plug this in, we get x equals the opposite of b, so negative 10, plus or minus the square root of b squared, so 10 squared minus 4 times a times c, so 4 times 1 times 9, all over 2 times the value of a. So that would be negative 10 plus or minus the square root of, what's 10 squared? 100. What's negative 4 times 9? Good, negative 36 all over 2. Yes, that will turn into 64 under the square root. And now I do want to keep going. Square root of 64 is a perfect square. So what's the square root of 64? 8. So we're going to have to determine what's negative 10 plus 8 and divide that by 2. And what's negative 10 minus 8? And we'll have to divide that by 2. So this will turn into negative 9, you're right. And what does this one turn into? Negative 2 over 2, which will give us negative 1. Because if you think about negative 2 over 2. Okay, so here's our answers, negative 1 and negative 9. How many solutions did we find? 2. Were they real or were they imaginary? Real. What in our work was different than the last 3 questions that we've done? Square root of a positive. Nice. Okay, the number under the square root is really what will tell you how many solutions and what type of solutions you will get. In higher level math, this is used all over the place to help you just kind of think through a problem and not have to do all of the work. In higher level math, well, in all of math, that value actually has its own name. B squared minus 4ac is called the discriminant. And that will tell you how many solutions you'll have and what type you'll have. So let's see if we can fill out this chart based off of what we just did. Here's the key. The discriminant is b squared minus 4ac. If that value is greater than 0, the first thing you want to think of is, what does it mean for something to be greater than 0? Does that mean that that number will be positive? It will be negative? Think about your number line. What type of numbers are bigger than 0? Positive. So if the discriminant is positive, will the solutions be real or imaginary? Real, because only the square roots of negatives could give you imaginary. And how many solutions did we get above when we had the square root of a positive? 2. So we will have 2 distinct real solutions. If b squared minus 4ac is less than 0, first thing you want to think of is, what does less than 0 mean? Does that mean it will be negative or positive? Negative. So go back and think when the square root was negative, What type of solutions did we get? Real or imaginary? Imaginary, nice. And how many solutions did we get? Let's go back to numbers 1 and 2. 2, because of the plus or minus. You always get plus or minus I, plus or minus I. So if the square root is negative, you're going to get 2 imaginary. And lastly, what if it's equal to 0?
Then that
You will have what?
one solution.
1 solution. Will it be real or imaginary? Real, nice. Okay, so let me give you an application question. I'm going to give you a random quadratic. 2x squared plus 4x minus 3 equals 0. Without doing the quadratic formula, can't talk. Tell me how many solutions you'll get and if they'll be real or imaginary. So how many solutions will you get? Will they be real or imaginary? Okay, the answer to this question, this is applying what we learned today. We'll just win a piece of candy. So I'm going to pick 3 Road Excellence winners today, but this one is just for you get to come up, grab a piece of candy. Raise your hand if you can tell me, how many solutions would you get? Would they be real or imaginary, and how did you know? Michaela?
But would it be positive and real too?
Nice. You would get 2 real solutions. And Michaela told me why she determined that. Because b squared minus 4ac is positive. So b is 4, a is 2, and c is -3. And if you do 4 squared minus 4 times 2 times -3, what's a negative times a negative, guys? Positive. So that's definitely going to be bigger than 0, which tells the reader it will definitely be 2 real solutions. Okay, your homework is a worksheet. Make sure to utilize the given solutions as needed. And I'm going to pick 3 Road Excellence winners. Michaela, come on up. Olivia, did you have any questions before? So no.
Nope, I'm good.
Okay, all right.